All right. Thank you all for showing up. We have a little while together. I see I'm down to 57 minutes. So 57 minutes together that we get to chat in here. I'm going to tell you a little bit about our vision for the role that robots play in the smart home, how AI really powers a lot behind that, how a robot's ability to understand the home provides spatial understanding, how that really provides a lever to help us realize the true potential of the smart home in our belief. So we'll talk a little bit about robots, what the state-of-the-art in robots look like today, how they're ideally positioned, given the role, the way they're used in the home, the types of things that they do in the home, that really sets them up to be that key to realizing a true vision of the smart home going forward. So this is what I'm talking about, like I said. So we have a little while to kind of walk through this story. I anticipate having some time at the end for questions. So I hope everyone, stay awake. Hopefully I'm entertaining enough to walk you through this story and keep you engaged. If not, I'll start calling people out. Vic, how you doing? Are you awake? Okay, good. We got Ross up here who's going to man the mic if you want to ask a question. He's the guy I'll look to help manage that process. So anyway, that's what we intend on spending the next 55 minutes about. So to begin with, it's important to set the context a little bit. iRobot is a robotics company. We've been around for 29 years. We've done robots in all sorts of different industries over that almost 3 decades. And it's important to note, just thinking about robots can be very different. When we're thinking about robots, what they need to work, how they need to think, how they successfully operate in the context that they're built for, very much means you have to be practical around designing them to really work in the environment and under the context you want them to work. So robots can be used in a wide variety of industries, whether it's hospitality, warehouse logistics, self-driving cars, medical, retail, whatever it is. Each of these domains, robots are showing success. You can see many examples of that in the tech showcase and through other talks here as well. But it's important to know that each one of these domains is unique. They have different requirements. If you're in manufacturing, you may have very high precision requirements. You can't tolerate anything that's not very, very precise, but maybe cost is more flexible. Some environments are structured. Again, manufacturing typically is going to be a more structured environment versus a robot in a retail environment, for example. Those robots have to be able to deal with the dynamic complexities of operating in a store where people are around the robot, the environment is very dynamic, and so on. All of this drives a lot of the way that the robot needs to think about the world around it, what AI means in these contexts, and what those robots can ultimately do. So there's a lot of breadth to robotics, what they can do, what's required to drive it, and so on. For this talk, we are completely focused on the home. So that's what iRobot does today. I said we've been in many industries, but today we're 100% focused around building an ecosystem or portfolio of robots for the home, and one that more deeply integrates into the home, into the smart home, and the other devices that might be in it in particular. So what we're going to be talking about is the set of technologies, the position of robots that would be in the home environment that's going to have, and we'll walk through these, its own set of opportunities and challenges that have to be addressed. If AI is going to be a practical tool in the environment, we need to tailor it toward the context that those robots are going to be operating under. So one step back, just to give some context, a little bit more on who we are and kind of where we're coming from. This is a chart. So the donut graph there on the left is overall global vacuum industry. Upright vacuums, robot vacuums at $200 and more. The green part of that donut are robots. So when we talk about robots in the home, it's real, right? This is, approaching a quarter of the market for vacuums globally are actually robots. So this is not a an individual, small-scale product in the home. This is a global business. It's building a real robot that's having an impact globally at scale. And the types of things we're talking about, or going to talk about how that presents an opportunity for those robots to really help power the vision toward the promise of the smart home. This is real today, right? This is a tool, a lever we all have that can be used now. And the other thing to note on that donut chart is growth. So the robot side is growing at 25% year over year versus 10% for non-robot. So this is going to continue to skew in the favor of robots over time. So again, this is a real category. These are real products operating at scale globally. And we're talking about how we can leverage platforms like that, like these robots in homes, to do a lot more. Secondly, for us, for iRobot as a company, we invest significantly into R&D. We don't view ourselves as a vacuum company. We view ourselves as a robotics company, and one that's using the tools, the expertise, the experience to really drive value for consumers today, consumers in the home. We have been and we will continue to invest significantly in R&D to continue to move that needle to realize these new opportunities for robots to have an impact in the home. We sold 25 million to date, robots globally to date. And then that right graphic is really intended to foreshadow a little bit that these products are connected, of course. These days, most of them are connected. And the way that they interact with other devices in the home, for example, Alexa, is an important part of realizing the vision to delivering kind of on the promise of robot vacuuming even. But it will also grow in other ways in terms of how the robots and their position in the home that we're going to talk about, that spatial understanding part of the title, how that can really be a very interesting input into systems around Alexa, for example, to open up these opportunities around the smart home. So that's foreshadowing a little bit in terms of how we view robots and how it's critical that they successfully, deeply, seamlessly integrate into other devices in the smart home. Okay, so we've just recently announced, and Colin highlighted it some this morning on the keynote stage, a portfolio of new robots. This is continuing that innovation cycle. These are not incremental improvements over the product. Roomba's been out since 2002, but the latest Roomba there on the far left, this continues that trend of significant innovation in coming into these particular products. And we'll talk more about that. The middle one is a new mopping robot, the Brava M6 robot mop. We'll talk more about it as well. It shares a lot of similarities to Roomba in terms of how it thinks about the environment it's operating in, the AI it uses to perform its task, how that presents an opportunity for multiple robots to be collaborating in the home to continue to drive more value back to the consumer. And then the robot on the right is Terra, our robot mower that we've recently announced. This is now taking robotics out of the home and into the yard, and it continues to build on a strategy of an ecosystem of robots that over time will increasingly work together to deliver a system-level value to the consumer in their home. So for us, we don't see these as individual products, right? This is a tight-knit family of products in the home. It's a portfolio. They're all connected. They're all intelligent. So we'll talk more about that, but they all have a lot of intelligence in them in terms of their understanding of the environment they're operating in, and they have the capacity to increasingly be able to team, to be able to work together, not separately, to continue to build on what they can deliver to the consumer. So I'm going to play a few videos just to give you the context of each one of those. So this is the new Roomba, the S9. It has a lot of capabilities inside this robot. We are pretty good at hiding a lot of the AI from the consumer, right? It does a job and it just does it well. But there's a lot of complexity inside the robot, of course mechanical complexity and so on to do the core job of vacuuming. But the intelligence inside that robot is something that requires a lot in order to deliver a very seamless experience for the consumer to just be able to say clean the home and don't have to worry about it. And that's an important part of Brava as well. Like I said, these two robots share a lot. These robots have a very similar sensor suite. They run very similar software that really is setting the stage, like I said, to allow them to be sharing and understanding of the space of the home, where rooms are in the space of that home. What are other characteristics about that home that over time they'll be able to share and like I said, perform in improved ways for the consumer. And then finally, Terra. A key thing to note here is this is a robot mower that always knows where it is. This isn't a mower that is kind of bouncing around the yard inside of some kind of constraining boundary. This is a robot that has technology that means it always knows where it is in the yard. It can do straight line mowing as it goes about this task to be very efficient and effective at taking care of the lawn. Okay, so if that's the portfolio, I've said several times now, it's setting the stage for them to be able to team. And at this point, we do have the ability for Roomba and Brava, the Roomba S9 and the Brava M6, to be able to team. You can actually use these two products, ask the system to clean the kitchen, and these robots will work together to do that in the most efficient and effective way, which can mean vacuum it first, right? How would you clean your kitchen? Vacuum it first to get up all the loose debris, then you go in and do a mopping mission. These robots have that capacity with a simple command to clean the kitchen. Ask Roomba and Brava to clean the kitchen, or Alexa, ask Roomba and Brava to clean the kitchen. Roomba will go systematically do a beeline through your house, go to the kitchen, vacuum it. When it's done, that automatically triggers Brava to go mop that same space. So for the consumer, you leave your house, you want the kitchen clean, let the system figure it out, go do it. You come home to a vacuumed and mopped floor. And then that will extend further through these types of technologies to not only allow the robots inside the house while you're not home to be taking care of in a coordinated way the maintenance inside, but to also be running the mower outside. So over time, these products and increasingly incorporating their integrations with other products in the smart home to be able to really deliver a system-level experience in terms of how these products are able to work together over time. So this is, I hope this isn't lost on you, right? This is an important trajectory. These aren't individual products. This is a portfolio of products that work together to deliver, increasingly interesting digital opportunities in terms of how they operate in the home. And it's key to, when we start talking about the smart home, where we're coming from, right? So it's important to kind of go over this background to set that up. Okay, so for us, we have robots in the home. That's great. We've been doing it for a while. We're going to keep doing it. We're going to keep pushing the state of the art and innovating along these lines. But it's important to then be asking, ultimately, what are we trying to do? We're trying to provide the value to in response to what the consumer really wants. They want the robot to complete its mission every time. They want the robot, if you tell it to clean the kitchen, it cleans the kitchen, right? I don't need to go program my robot. I don't need to do a lot of complex setup. The robot needs to very reliably figure out how to do that. And that may mean teaming, right? It may mean multiple robots or multiple devices that need to figure out how to coordinate or work together to go do that. But at the end of the day, for cleaning robots, the consumer just wants wants the robot to complete its mission. Go do it. And of course, they want it to be clean, right, for the floor care. They just want those clean floors. And again, that clean floor could mean I need to vacuum before I mop, for example. And then ease of use is something, to hit on it directly. I've been kind of saying this, but this has to work very seamlessly for the consumer. So the promise of a robot vacuum, specifically, let's say, is I just want a clean home. I want to ask, let's say, set my Roomba off cleaning my home, and I just want it clean on a schedule. It has the clean base, so it'll evacuate the dustbin of the robot on its own, so you can go for months or a year at a time without touching your robot. It just does what it needs to do. Very easy for you to kind of deal with. So it's that ease of use for us that's kind of very important to how we think about getting technology in the product at the end of the day that enables a very seamless and compelling user experience in terms of delivering the benefit that they bought the product for in the first place. That's where a lot of the AI we'll talk about kind of starts coming into play. It's giving them the opportunity to have their robot increasingly understand their home, know how to respond to it, know how to adapt to it, so it really optimizes what it can do within the specific context of the space of your home and the activities that it might encounter. So those are the products that we kind of have now. These are kind of some guiding lights to deliver on the promise of robot vacuuming or robot mopping or robot mowing, kind of in a general sense. But it's not without its challenges, and I'll focus inside the home kind of at this point. I said before that robots kind of operate in their own context and their own environment. They all have their own constraints, their own nuances that they have to deal with. Everything is different, right? You don't design a industrial automation arm in the same way you would design a floor cleaning robot, right? It's a very different context that we need to be very sensitive to. So for us to deliver on that promise of vacuuming, in this case, for example, we have to deal with mobility. Like, this isn't an easy problem. If you want the robot to be able to navigate all floor types, there's no excuses, right? If you buy a robot and it doesn't work on, the particular floors you have in your home, right? It needs to be able to robustly deal with that. Transitions onto carpet, over thresholds, and, old New England homes, right? It really has a lot of mobility challenges that have to be effectively dealt with. So, going back to what I said, so it completes its mission every time. Like, it actually goes and cleans the whole home when you ask it to. So that's an important part of what we do. There's a lot of sensing in that, in terms of being able to detect if you're entrailing kind of a rug tassel, for example, to be able to sense that and reverse course, to be able to eject it. There's a lot of things like that, behaviors to get off of high thresholds and things like that. It's important, right, to deal with, confront head on, right, the mobility challenges that these robots have to deal with. They're working, when I say movement, they're working in dynamic homes. So this isn't like a home that's pristine for robots, right? That's set up, okay, it's perfect, we finally got it right. It has to deal with moving things. Furniture will move, people will move, right? Objects in the home, the floor type will change. New rooms might be opened up to the robot. It needs to discover these things and deal with that, in general, that dynamic nature kind of the of the nuances of the home. So all of the AI we might have to include or deal with needs to be able to accommodate, and help us deal with all of these challenges. Obstacles, of course, a home is littered with them, right? It needs to effectively deal with that. And for us, for floor care, it really needs to be fairly aggressive at trying to get everywhere it can, right? It can't kind of shy away from, that looks a little difficult, right? You really want the robot to really push to get everywhere it can to effectively clean and accomplish the mission it set out to do. So it needs to effectively deal with, in very close proximity, all the obstacles it's going to encounter throughout the home. And then the last one for us, lighting conditions is important to note. We'll talk in a minute, but we use computer vision for a lot of what we do. And that means that a robot is going to be perceiving the world. It's going to be trying to understand the context it's operating in, what the environment's like, where it is in the home, using a camera. And in order to do that robot has to be very robust to changing lighting conditions. It's no excuse if you shut the shades and it's a little dark, right? Because if the robot was originally encountering the home in full sunlight and so on, it needs to understand how to adapt to that. So it's not an easy computer vision problem to deal with. So we have to deal with all that with no input from the consumer, right? You don't want to have to have the consumer do some kind of special hands-on programming or tweaking of parameters, right, to help get it to adapt to these things. It needs to do what it needs to do to figure these things out. But if you overcome these challenges, if you have a product that delivers value to the consumer, right, you're at scale, you're doing something real in the home, it's robustly able to operate in the home, And for us, with robots in the home that systematically cover the entire home, you find yourself in a very unique position. This is a product that has a position in the home that's unlike any other. This isn't a static sensor on a shelf. This is a robot that in the models that use vision, that through its camera with onboard processing, it actually sees the full visual richness of the world. We may selectively, use that in different ways or reduce the complexity of it in different ways, but it has the opportunity to see a full visual richness of the space of the home, which sets you up for a lot of that robot to understand more about the context it's operating in. So it's exploring the home with a very rich multimodal view of what the space of that home is like. The second one, it always knows where it is. So this is, if you want to deliver a functionality where you can ask your robot to clean the kitchen, it has to know where it is, right? The consumer might have picked it up and kind of threw it down in a room and then said, clean the kitchen. The robot needs to figure out where it is quickly and then get to the kitchen to clean it, right? It always needs to be able to figure out where it is in the space of that home, realistically, without any other infrastructure, right? There's not, things all over the home that you have to calibrate or place. It just needs to look around and figure it out. So you have a platform that always knows where it is with rich sensors on it. You have a platform in Roomba and Brava that, because of their mission, persistently cover the home. Whenever they go out to do a mission, it's not just a kind of a quick drive-by pass, right, through big parts of the home. It is systematically exploring everywhere it can get in that space because it's got to clean the floor. So it's exposed to everywhere that it can physically get kind of in the space of that home. It's not on a shelf. It's not got one view of the world all the time. It is constantly kind of moving and being able to increasingly understand the context it's operating in. And again, because of the mission of our products, they typically and very frequently run on a schedule. So they're not run occasionally. They're run on average every 2 days. So if you kind of add all of these things up, if you start thinking about the asset you have in terms of the smart home, you have a platform that has a very rich view of the world of that home. It always knows where it is. So when it's seeing something that's interesting or relevant to understand about that home, it knows where it is, right, within that space. And it's constantly looking, kind of covering everywhere on a schedule, so it's very much maintained, right? It's constantly keeping an updated view of an understanding of the space of that home. And this is a good point to pause for 1 second and say, we put a lot of effort into running all of our computer vision, all of our AI on the edge, right? This isn't something that's streaming to the sensor data to the cloud. This is something that robot is processing on the edge to extract what it needs to do its job, and it can go, right? It's not dependent upon the cloud. It's not sending this data in terms of the raw sensor data to the cloud, et cetera, right? You can never depend on a robot always being connected anyway, right? It's not always going to be connected everywhere in the space of the home. It's important for more responsive real-time operations that it's happening locally, and it's also important in thinking about this from a privacy or security perspective, that these are things run on the edge and not sent to the cloud to do things like computer vision processing. Okay, so I hope I've convinced you that, at least now as we've kind of walked through robots specifically here, that what the industry has available for itself now is a platform in the home that has quite a unique perspective on the home that's already deployed at scale and ready to be used as a lever, right, to help improve our ability to deliver on the promise of the smart home. So I'm going to talk a little bit about some of the underlying kind of AI that's powering some of those things I just talked about, give you a glimpse into our roadmap of some things that we're excited about that contribute to the story of an understanding of the home. Then we're going to talk a little bit about robotic thinking, how robots go about thinking in terms of doing their job, what's the kind of the paradigm in terms of how they process the world and decide what to do, and then make a direct parallel to, actually not only can the smart home benefit from the understanding of the home that robots have, but actually the smart home could actually benefit by thinking like robots do. Because at the end of the day, I'll make a case, that the smart home is actually just a robot. It's a distributed robot in some sense. But it in and of itself is a robot. So hopefully I can convince you and twist your mind a little bit to view robots in a different way than you might have seen them as a vacuum cleaner kind of in the home. That's the path, a path that we're on. So robots, I've mentioned this some as we go. This is not just a simple piece of plastic with some motors in it, right? This is a platform. It's got a compute platform on it that's very robust to do all these things at the edge we talked about. Of course, they're connected, a variety of sensors, including a camera, other navigation-based sensors on the robot, all packed into this consumer product that's being deployed around the world. The second, the mobile, the home map UI. This is an important point here. We are already interacting with our consumers with a view of a space of their home. They are able to see an understanding of the layout of their home as maintained by their robot, because they need to do that to be able to say, I want you to clean this kitchen, right? They are becoming familiar with how to interact with these products, thinking about the space of their home. And then finally, of course, we can't do this for our connective tissue, right, back to the consumer. We do have a very robust cloud infrastructure around AWS IoT that helps us power, maintaining that connectivity back to the consumer. Okay? So it's not a piece of plastic, right, with a couple motors in it. It's a pretty complex platform that has a lot of opportunity for software updates, digital features, and so on to be rolled out over time. Let's cut off a bit, apologies. So I mentioned how the robot navigates a minute ago using a camera, just to always figure out where it is. Just a kind of a one slide on this to think about how that works. So, we do use a visual SLAM system, visual simultaneous localization and mapping, that uses a single camera with onboard processing that allows that robot, in effect, to pull out a whole constellation of very discrete visual features. It's not seeing the world like you and I do. It's seeing the world in these very discrete patches of pixels that it's remembering, and a constellation of them in a known kind of geometric pattern, and then using those everywhere around the home such that, when it's placed down and needs to figure out where it is, it's kind of like celestial navigation, right? It's looking up, it's looking for those stars in the sky, those discrete visual features, looking for a constellation it recognizes that then tells it, okay, I know where I am, right? I'm precisely here facing this way in the living room. So then it can go figure out how to get to the kitchen if that's what you've told it to clean. So we use that camera. We use other sensors on the robot as well to maintain kind of incrementally how it's moving through the space of the home. But that visual scene, that visual perception of the home is very important here. There are other ways of tackling this problem that you might see out there. Scanning lasers, for example, sounds expensive. But it's also one that, if you think about it, by investing in the technology to do vision-based navigation, you see that full visual richness of the home to be able to figure out where the robot is, understand the context, as compared to seeing the world in kind of a very narrow slice, right? Which is what other approaches might do that are very limited, right, in terms of how far they can take that technology. So we've put a lot of investment, a lot of focus behind leveraging computer vision and advances in that field to power the intelligence behind the system in our robot. And we'll talk more about that in a minute. So if it always knows where it is as it's driving around, whenever it encounters anything, right, the bumper touches something, any of the short range kind of IR sensors encounter something, it can kind of put a dot down and say there's something here, which over time, if you keep doing that as it explores the home, you end up with a blueprint, right? You end up with a geometric understanding of the space of the home. So this is a robot that's going around cleaning the home. There it saw a constellation, for example. So it knows where it is, keeps that updated over time. So this robot will go out and clean. It knows where it's cleaned, where those unexplored frontiers are that it hasn't explored yet. If it needs to recharge, it knows how to get back to the charging station. And then once it's charged, go out and finish where it left off. So this is something that over time, the robot will increasingly begin to maintain over time. So it's these days, it's not necessarily a one-shot deal, right? It's actually over the life of that product will increasingly start to remember the space of the home, understand how things are changing so it can better adapt to the space in that home. So if you put all those things together, you end up with a map that looks like this. This is that map that then can get kind of presented to the consumer so that they can interact with the space of their home and say, I want this area cleaned, I don't want this part of my home cleaned, et cetera. Okay, so where that takes us, home mapping, so there's the map of the home on the left, as presented today in our mobile app. The one other thing you can see today for Roomba 900 series is the Wi-Fi signal strength map. So it's just a fun thing to think about that kind of demonstrates some of the things I was talking about. This is a robot. It always knows where it is. It's exploring everywhere in that home. It has an opportunity to very densely, very frequently, just sample your signal strength. You put all that together, you end up with a signal strength map of your home. You can see exactly where you have Wi-Fi, where you don't have Wi-Fi, where it's weak, which might be causing a connected device connectivity problem, for example, where you might want to put a mesh node or move your access point, right? So that's just an interesting piece of an understanding of the home that the consumer might be able to benefit from. But it's kind of foreshadowing some of the types of things that really continue along that trajectory that are exciting. So today what this means with the home mapping bit, like I said, you can of course schedule a cleaning job. You can ask Roomba and Brava to clean the kitchen. One command, those robots will coordinate to go clean the space called kitchen to get that done. That's today. That's shipping, that's product, that's out there today. To talk, I said talk a little bit about a glimpse into a roadmap or direction that we're thinking that's very relevant to smart home, how robots can play a role in the smart home, et cetera, are things like this. So I mentioned that we've invested a lot in computer vision, continue to invest a lot in computer vision. We have the ability to see the world in that full visual richness. As I think many of you know in the room, computer vision, visual scene understanding, visual object recognition is advancing very quickly. Like this is something that's real. It wasn't a few years ago, but it's real today. This is something in the directions we're going that you end up with a robot that starts to understand, oh, that's a chair, that's a lamp, that's a fridge, right? It can understand that context of the home, which if you look on the right, some of these new, the Alexa commands that eventually would enable are things like ask Roomba to clean around the dining room table. To be able to process that, the robot needs to A, know where the dining room is, B, know where the table is in the dining room, which may have moved, right, since the last time maybe that robot's encountered the dining room. If you want to go deliver that feature to the consumer, if they just want to get the things clean that they want cleaned, you would like to give them the ability to say things like this. Go mop in front of the dishwasher. Go vacuum in front of the dryer. Or even better, go vacuum around the dryer when the cycle's done, if you have a connected dryer, right? So any lint that got thrown up at that point, when the dryer's done, trigger a robot to go just clean that space. So that's why these types of things are really setting the stage for a contextual understanding in the home that these robots can have that can drive some really fantastic user experiences, some fantastic features for the consumer. The middle column, let's talk about that for a sec. So think about the Wi-Fi device mapping. the Wi-Fi signal strength mapping. Now translate that to just listen to signal strength of any device on the network. You can get the robot to actually start finding every Wi-Fi device in the home so that consumer can start to piece together, where is the space in my home? What's the connectivity around these devices in the space of my home? I see where my Alexa is. I see where my connected dryer is, right? The robot has been able to very densely sample signal strength, let's say, to that very particular device in order to figure it out and put a pin in the map. That's where that dryer is. That's where that smart speaker is. I see you moved it since yesterday, but there it is, right? So you end up with a map that starts to be annotated with even more context. Where are connected devices in the home? Where are the connected light bulbs? Where are the connected switches, smart speakers, TVs, right? This is going to start, right, playing into the smart home story. And then finally, with the visual scene understanding, you put furniture, appliances, things like that onto the map as well. So again, you might say, ask Roomba to clean around the dining room table, ask Roomba to vacuum around the dryer when the cycle's done. It has what it needs to go do that, right, with this type of information. And then over time, right, this continues to be kind of looking forward, through federated learning, things that can allow robots to incorporate a new understanding of how they're encountering things, kind of factor that into the models that they might have individually in their own memory, and then be able to use those kind of, let's say, deltas, right, to be able to help the rest of the fleet also improve. So this is an exciting kind of opportunity or future direction where these robots can have a balance of being able to kind of improve themselves and use that to improve everyone, which means everyone's robot gets better based on all the experiences that other products in the home might have, other robots in the home might have encountered as well. Okay, so I said next up is how robots think, and then translate that into how smart home thinks, how the smart home thinks. So a robot, it's important to note that a robot is a physical thing. This is not a piece of software only. It's a physical thing, right? It has a physical presence in the space of the home. It has to sense that home in order to do something useful, right? So a robot is a physical thing. It needs to sense the physical nature of the space around itself in order to figure out how to act to do what it needs to do. So if we break that down a little bit, sensing. So things like Roomba have a lot of sensors in them. Robots tend to have a lot of sensors to help it navigate, help it understand obstacles around it, help it detect a drop-off for stairs so it won't drive down the stairs, help it to detect objects in the home like we were just talking about. All of that contributes to the robot sensing the home. It needs to understand the space it's operating in if it ever wants to have a chance of doing anything useful. Robots can act, of course, drive their motors. Maybe Roomba increases or decreases vacuum power based on if it's sensed it's on a carpet or not, right? Hardwood or carpet, right? It has a lot of actuators to change what it's doing, to physically affect change in the world, whether it's moving the platform around, vacuuming, whatever it might be. A lot of ways to kind of act. But a very important part is a robot's ability to think, is closing the loop between sensing and acting based on thinking about the space of the world that it's in, right? It's a physical device in a physical world. It needs to think about that physical space if it wants to act reasonably. So in this case, right, if a robot is sensing that its charge level is low, it needs to figure out how to get back to the charging station. And if that robot has an understanding of the space of the home, that's an easy problem, right? You just plan a path through the blueprint of the home. You get back to the charging station, recharge, and you can go. So that thinking about the space of the home is critical to having an intelligent robot in the home. And I'll go one step further, right, in saying that in this case, the importance of spatial understanding, importance of being able to reason about the physical space of the home. If you have that understanding, the AI problem is actually easy, right? If you know the space of the home, if you want to get from point A to point B, if you want to go clean around the dining room table, if you know where the dining room is and you know where the table is and so on already, it's easy. It's not a hard problem to go figure out what you need to do, to go act to solve that problem. AI becomes easy. There's a lot of AI in the spatial understanding, I'll say, but once you have that, there's a lot of AI that is simplified to use it now to do a lot more sophisticated things for that robot. Imagine if you didn't have spatial understanding of the home and Roomba wanted to find its way back to the dock to recharge. That's a pretty hard problem. It has no idea where it is. It has no idea where the dock is. There's a lot that has to go into thinking about how to be effective, at least, right, at trying to find how to get yourself recharged in that context. Just having a map kind of solves all of that problem for you. Okay? So, the last segment here is now translate that into the smart home. So let's pause for a second about what we mean by smart home. So I said the promise of the robot vacuum, right, was you just want a clean home. You want the product, you want to say clean my home, it does its job. Maybe you never touch it for a year, it just persistently does its job. That's the vision. You can do exactly what you need it to do. On the smart home, if you think about what would the equivalent promise of the smart home be? You really want a smart home that just does the right thing, right? You may have a bunch of devices in your home, connected devices, lights, locks, audio, whatever it might be. The average consumer, the mass market consumer, is not going to invest time to program that home, to set up all the nuanced rules of if this sensor does this, then this light should do that. If this door opens here, then this light needs to turn on to give light in the entryway. They're not going to set up all of those logical rules, not the mass market consumer. Probably all of you do, but not the mass market consumer. The vision of the smart home is it's just simple, automated, and personal. You get the requisite hardware in your home. It's very simple to set up, right? You get your hardware in. You say, I'd like an experience that when I walk into a room, the lights turn on without really saying any more. The home can then figure out what to do with that. It's automated at that point. It can reason about, well, how would I link up presence in this space? How do I give lighting in this particular space of the home? And it's personal because it has to be customized to your home, where your lights are, right? Where your motion sensors are, what the layout of your house looks like. It needs to be personalized to you. So you would want it such that any consumer, right, is able to get the requisite hardware, and then it's very simple to say, these are the experiences I would like my home to give me, and then the home does the hard work. It makes it very simple for you. It automates the execution of those experiences at the right time in the right place, and it's very tailored to your home, right, to your lifestyle, your home, how you live in the space of your home. So that's the promise of the smart home. So I told you I was going to make a connection to robots, right? So these are robots. I think we all probably recognize that. I already told you, this is a robot too, right? The smart home, this is a robot in the exact same way we just talked about Roomba. And let's walk through what that means. What does that imply now for how do we realize that vision of the smart home? How do we realize our ability to deliver on that promise of the smart home? So this was a robot. Think about it. What's a smart home? What's a home? It's a physical space, right? It's an embodied, like a physical space. It has to sense the world. If you want your smart home to do things like turn the light on when this motion sensor goes off, it has to sense the world, has to understand what's happening, at least to some degree. It has to do something about it. It's not a very useful smart home if all it does is sense everything, right? It needs to then use that to intelligently do something for you. So linking up sensing and actuation in that home. So if you think about it, I mean, the smart home is a robot. It's got sensors, it's got actuators, it's a physical space, right? Exactly the same way. And the way we think about this is just like robots. This spatial understanding is key to delivering on the promise of the smart home. For Roomba, it was key that robot understands a map of the home if you want it to clean the kitchen, if you want it to go efficiently back to the dock and recharge and go finish, right? It's going to be the same thing with the smart home. If you really want to deliver on that promise, that home also needs to understand that rich spatial context, that spatial understanding in order to do so. So if we think about it here, sense, think, act. We just went through this. Let's go through it for the home. The smart home, there's no shortage of sensors, right? You can go buy all sorts of things, leak sensors and light sensors and motion sensors and temperature, humidity, whatever it is, right? There's all sorts of sensors you can put in your smart home. That's not holding us back as a smart home industry. Smart home has actuators, also not holding us back. You can buy all sorts of stuff that affect change in the home, right? What's missing is the thinking part, that embodied thinking about the spatial understanding around that home to deliver these experiences. And that is leaving us at a place where a lot of the smart home is very simple integrations, right? If this happens, do that. And it may be manually set up, right, through rules by the consumer. It's a very manual process, very limiting in terms of the complexity or the richness of the experience that can be provided. But what happens if that home starts to have spatial understanding? So let's walk through it for a second. So imagine that home has a map. This looks very familiar, right? These maps are already being built. Imagine the home has it. Imagine the home knows where the rooms are, what they are in the space of that home. Imagine it knows where your smart home devices are in the space of that home. Not just that you have them, but exactly where they are. Imagine it knows where unconnected things are, furniture, appliances, architectural features like stairs, windows, doors. All things that could be done by through the means we were talking about earlier. Imagine your home has this. Your smart home has this at its ready, right, to try to deliver an experience for you. So what might an experience look like? To be simple, automated, personal, right? If is off the table here. You can't do a lot of manual configuration. If this homeowner wants to have the ability to say, that IP camera just detected motion and it's pretty dark. It would like, it can see okay in the dark, but it would actually like light. That this smart home would like to say, give me light wherever this camera sees, because we have an event. I want to capture it fully. If the home has this, all this spatial understanding, it's pretty easy to figure out which light to turn on, right? It's not rocket science at this point. If you didn't have all that spatial understanding, there's a lot more complexity you have to figure out here as to how to figure out which light to turn on to affect this camera. The camera may have moved, so I need to be able to keep all of these things up to date. So it's easy to solve that a problem and deliver that experience in that case. Imagine you want to say, turn on the lights by the couch in the living room. Sounds a lot like clean around the couch in the living room, right? But if you want to say, Alexa, turn the lights on by the couch in the living room, if you have this representation, it's pretty easy to know which one to turn on. You have the home has everything it needs at this point to make that an easy problem to solve. And this is mirroring the other slide I just said about robots. If the smart home has spatial understanding, like we just talked about, the AI problem is easy, right? If the home has that spatial understanding, it knows where the layout of the home is, where the rooms and the walls are, where the devices are in the home. Delivering on those types of experiences, consistent with kind of that promise of the smart home, is actually a fairly easy problem to deliver at this point. Versus if you don't have that spatial understanding, it's not so easy. So this is getting close to the end. What we're saying here, right, just to summarize, is, as an industry, we're at a cusp here. If you start thinking about combining things that we already have, that are already in homes around the world, you have a platform that builds spatial understanding. That it already has to, for us, to deliver on the promise of robot vacuums, right, where this is already happening out there today. You add in an ecosystem of devices that provide a natural interface into that smart home, things like Alexa, giving you connectivity, giving you the ability to naturally interact, to ask for the lights around the couch to be turned on. You kind of have the critical mass of stuff you need to actually go deliver on the promise of the smart home. So I think this is, for us, this is what's motivating, inspiring, and driving us, is realizing that the tools are all here. It's a matter of working to put them together to deliver those experiences for the consumer that will really, in a step change way, change our ability to deliver on the promise of the smart home. Okay, so just one note, a couple notes here at the end. We do have a home understanding developer portal. This is something that's new for us in an early access program where we are exploring, talking, working with some select partners that have a core need to use spatial understanding of the home that would make their products better in the space of that home. And the way we think about this, right, is allowing consumers that have these products in their home to elect to be able to take advantage of that spatial understanding that their robot has, and under their full knowledge and control, allow that understanding to be shared with the third party for that consumer to get a better smart home out of that experience. So we're talking with folks who are interested in working with us on piecing together, making steps toward that full vision on delivering on the promise of the smart home using spatial understanding. So if you'd like to learn more, here's some information. Come see me afterwards. Would love to hear your story. And then finally, you can go see all these cool robots in the showcase downstairs. Go to the Alexa and iRobot smart home. They're all running live demos. Kick the tires metaphorically and kind of see how this technology is already working. These robots are already working in homes today. And with that, we have 7 minutes. So if there are any questions, I'd love to have a conversation.